In this video, we're going to take a look at representation of functions as power series. In this first example, I have f of x is equal to 3 divided by 2x minus 1. And for this function, I'm going to rewrite this as negative 3 divided by 1 minus 2x. And I'm going to do that, and then I'm going to write the basic model for the geometric series, and so we can see how this relates. N is equal to 0 to infinity of a to the r raised to the n is equal to a divided by 1 minus r. So now that we can see a divided by 1 minus r, and now we have negative 3, which represents a, so we can say that we have the series, and remember, a is equal to negative 3, and r is equal to 2x, so we have the series from n is equal to 0 to infinity of negative 3 times 2x raised to the n. And now if we want to find the interval of convergence, remember that 2x has to be less than 1, so we have 2x, the absolute value of 2x has to be less than 1, and then we're going to say that negative 1 is less than 2x is less than 1, and now we divide by 2, so we have negative 1/2 is less than x is less than 1/2. So we have a radius of convergence, or r, of 1/2, and our interval of convergence is negative 1/2 to 1/2. And our power series for this function is n is equal to 0 to infinity of negative 3 times 2x to the n. In the next example, we have f of x is equal to ln of x plus 1. And for this, it's important to remember that the integral of 1 over x plus 1 dx is equal to the ln of x plus 1. And then we could also rewrite 1 over x plus 1 as 1 over 1 minus negative x, which is going to help us out in this as well. And then we can say that 1 over 1 minus x is equal to the series from n is equal to 0 to infinity of x to the n. So now I can say that ln of x plus 1 is equal to the sum from n is equal to 0 to infinity of the integral of negative x raised to the n dx. And now I can also rewrite that as negative 1 to the n times x to the n dx. And now I want to integrate, and I'm going to put my coefficient, my constant of integration out front, so I'm going to have c plus the sum of n is equal to 0 to infinity of negative 1 to the n x to the n plus 1 divided by n plus 1. And now in order to solve for c, we're going to let x equal 0. So let x equals 0 solve for c. And if x was 0, then c would be 0. So our series is going to be the sum from n is equal to 0 to infinity of negative 1 to the n x to the n plus 1 divided by n plus 1. And now in order to find our interval of convergence, we're going to use the ratio test. So we're going to have the limit as n goes to infinity of negative 1 to the n plus 1 x to the n plus 2 divided by n plus 2, all divided by a sub n, so negative 1 to the n, x to the n plus 1 divided by n plus 1. And now I'm going to rewrite this as a multiplication instead of division, and I'm going to rewrite some of my factors. So I have the limit as n goes to infinity of negative 1 to the n times negative 1. And then I'm going to rewrite x to the n plus 2 as x times x to the n plus 1 divided by n plus 2 times n plus 1 divided by negative 1 to the n x to the n plus 1. And now I'm going to cancel factors that cancel. So negative 1 to the n, negative 1 to the n, and x to the n plus 1, x to the n plus 1. So now I'm left with the limit as n goes to infinity of n plus 1 divided by n plus 2 times the absolute value of x, and that equals the absolute value of x. And the absolute value of x needs to be less than 1 for convergence. So our interval of convergence is negative 1 is less than x is less than 1. And that's our video on representation of functions as power series.